How do you program PLCs using structured text, STREET? Imagine being able to write code that controls machines just like programming a computer. That's what programming programmable logic controllers using structured text is all about. It's a way to tell industrial machines what to do with clear, text-based instructions. Structured text is part of the EC 61131 standard for PLC programming. It looks similar to languages like Pascal, C, or Python, but it's made for automation. This language is perfect for complex control tasks, math operations, and managing data that can be tricky with graphical languages like ladder logic. To start, you need to understand the basic structure. A typical program begins with a block called program and ends with an program. Inside, you write lines of code that run one after another during each cycle of the PLC's scan. Each line ends with a semicolon. You use keywords like if, then, else, for, while, and case to control flow. Variables, which are called tags or symbols, representing inputs, outputs, timers, or internal data. Comments can be added with delimiters like comment or to explain what your code does. Before writing logic, define your variables. For example, create a bool variable for a start button or a real variable for sensor readings. Use meaningful names so your code stays clear. Data types like bool for true or false, int for whole numbers, and real for decimal numbers are common. Control logic is written with if statements. For example, to turn on a motor when a start button is pressed, you write, if start button then motor relay is equal to true, end if. This makes decisions easy to follow. Loops like for or while help repeat actions, such as checking multiple sensors or running a process several times. Mathematical operations are supported too. You can add, subtract, multiply, or divide numbers, and use logical operators like and, or, and not. This allows for advanced calculations and data handling within your program. To keep things organized, write functions or function blocks. These are reusable pieces of code that make your program modular and easier to troubleshoot. Comments and consistent formatting improve readability. It's important because in industrial settings, others might need to understand or update your code later. After writing your program, use the PLC software's simulation tools to test it. Monitor variables and flow to catch errors before deploying. Once everything runs smoothly, download the program to your PLC. The controller will then run it repeatedly, reading inputs, executing logic, and controlling outputs. In modern factories, structured text programming helps implement complex control algorithms needed for smart manufacturing. It handles data processing, integrates with analytics, and supports scalable, flexible automation systems. This makes it easier to deploy standardized control across multiple machines, speeding up setup and maintenance. Plus, because it's text-based, teams can collaborate more easily and keep track of changes through version control. In short, programming PLCs with structured text is about writing clear, logical code that controls industrial processes efficiently. Its similarity to traditional programming languages makes it ideal for advanced automation tasks in Industry 4.0 environments, where flexibility and data handling are key.